In this video, I'm going to review a variety of topics. We'll look at measures of center and spread. So, for instance, mean, median, and mode. For spread, we can look at range, variance, standard deviation, the interquartile range. And we'll also look at regression, linear regression, so a way of analyzing the relationship between two variables. So I'm going to be using this data set. Basically, I have data from the borough of Queens in New York and then also in Nassau County. So I have sample data from each of these areas where I have the square footage and the rent for apartments here in Queens, and then so this is the square footage of an apartment, 500 square feet, and the rent for that apartment was $650 a month. And similarly in Nassau County, I have data on square footage and rent for various apartments. So let's get started, and let's look at the square footage for the apartments that are in Queens. So I'm going to turn to my calculator to do a lot of the work here. So I've started out by putting all of the data in list. So in list 1, I have the square footage for the apartments in Queens. List 2 is the rent in Queens. In list 3, I have the square footage for the apartments in Nassau County. And then if I scroll over to list 4, those are the accompanying rents for those apartments. So let's start with an analysis of the square footage for apartments in Queens. So from my stat menu, I'm going to first of all do a calculation, just this one variable, and my data is in list 1, and I'm going to make a note here. So these are square footage in Queens. So I see that I have a mean, this is from the calculator, of, let's see, I can't put it like this, take the glare off a little bit. The mean is 863, and I'm going to round, keep one decimal place. And let's see, I want to also know, make a note of the standard deviation. In this case, it's with sample data, so I'm going to use the sample standard deviation. That's the S with a little X after it. That is 343.9. These are both in square feet. Okay, let's also take note of the 5-number summary. So I have a minimum Q1, the median Q3, and a max. And I'm going to just write all this information down. So the minimum was 460, so that was the smallest apartment. The Q1 was 574. The median was 756.5. Q3 was 1166, and the max is 1452. From this, I can derive the overall range and the interquartile range. So the range is going to be the maximum minus the minimum, so 1452 minus 460. And the interquartile range is just the difference between the third quartile and the first. So that will be 1166 minus 574. So let's see, I'll go to my home screen and say 1452 minus 460. So between the smallest apartment and the largest apartment, there's a difference of 992 square feet. And for the middle half, the range of apartment sizes is 592 square feet. One more thing I'll add here is the variance. Remember, that's the square of the standard deviation. So if I take 343.9 to the second power, this would be 11,8267.21. Don't be surprised, that the variance is a large number. Remember, we're squaring some something over 340, so we do get a large number for variance. Okay, so what can we say about, just from what we've done so far? Well, I know that the mean gives me an idea of what's typical. So in Queens, a typical apartment is just under 900 square feet. More specifically, it's about 863 square feet. Now, another measure of what would be typical would be the median. That's 756.5. So half of the apartments are 756 square feet or under, and half are 757 square feet or above. So I kind of know what's typical as far as size. Because the mean is greater than the median, I also have a suspicion that this is skewed to the right. There are some values at the high end. Maybe this apartment, which seems large, is pulling the mean up. So it's might be inflating the mean. So I'm just going to keep in mind that this might be skewed to the right. Let's see. What else can I do? Well, let's see if there are any outliers. So I'm going to find my lower fence and upper fence for outliers. So for this, I'll take Q1, which is 574, and subtract 1.5 times the IQR, which was 592. And for the upper fence, I'm going to take Q3, which is 1166, and add 1.5 times the IQR. So 574 minus 1.5 times 592. That's negative 314. I'm not going to have to worry about outliers on the low end because it wouldn't make sense to have an apartment with a negative square footage. But maybe on the high end, so let's say I've got 1166 plus 1.5 times the IQR, which is 592. Oops, I don't need that. So that's 2054. So I know that the maximum was 1452. I don't have anything above 2054. So there are no outliers on either end, on the low end or the high end. What about a box plot? I'm going to give myself some scale here. I know that these range from 460 up to just over 1400. I'm going to make my scale starting at 400. Let's see there. I'm going to increment by 200. There's 8, 1,000, 1,200, 1,400, 1,600, 1,800, 2,000. That's plenty. And so I'm going to construct the box for the box plot. The Q1 is at 574, so this would be 500. So I want to say that that's about where my Q1 is. The median is at 576, so I'm sorry, 756. So here's 700. This would be about 756. And then Q3 is at 1166. So this is 1100, and there's approximately where 1166 would be. And what about the whiskers? So the minimum is at 460, so that might be about right here. And I don't have any outliers, so I'm going to extend the whisker on the right hand side to the maximum, which is 1452. So about right here. So there's a box plot. I can see that there does look like there might be a slight right skew in this data. So let's look at the information for the square footage for apartments in Nassau County. So I'm going to look for the same information. I'll go back to my calculator and in the stat menu, calculations. Again, I'm going to do one variable, statistics. This time I'm looking in list 3. So I have a mean is 992.4. The standard deviation is 393.4. And then I need the minimum, Q1, the median, Q3, and the max. So I'll scroll down, and I find that the minimum is 556, Q1 is 701.5, the median is 900, Q3 is 1175, and the max is 1906. And again, I want to find variance, which is S squared. So I'll take 393.4, and this is 154,763.56. And I'll also find the range, the IQR, and a lower fence and an upper fence for outliers. So the range is 1906 minus 556. The IQR is 1175 minus 701.5. So 1906 minus 556 is 1350, and 1175 minus 701.5 is 473.5. All these are measurements are in square feet. So for a lower fence, I need to take my Q1, which is 701.5, and subtract 1.5 times the IQR, 473.5. So 701.5 minus 1.5 times 473.5. That's a negative value, negative 8.75. Not going to have to worry about outliers on the low end. What about on the high end? So I'll take 1175. This I'm going to add 1.5 times the IQR, 473.5. So 1175 plus 1.5 times 473.5. And that's 1885.25. So I notice at least one value is higher than that. So going back to the original data, I think that's the only value that's higher than 1885 is just the 1906. So let's look at a box plot for, so this was for Queens. So just below it, I'm going to have a box plot for Nassau County. So Q1 is at 701, so that's about right here. And the median is at 900, that'd be here. Q3 is at 1175, that'd be about right here, so I'll connect those to make the box. For the minimum, I have 556, so that would be about here. And for the maximum, I have 1906 down. This is actually an outlier, so I want to make sure that that's very obvious. So over here at 1900, and a little bit to the right of that, I'm going to put a little asterisk. So this whisker will extend to the largest value that's not an outlier. So looking back at my original data, the largest value that's not an outlier, I think, is this guy, 1429. So 1429 would be about here. Now, without this outlier, this is a fairly symmetric distribution. The tail on the left is similar, or the whisker on the left is similar to the whisker on the right, and it's roughly, you could fold this over on top of itself. But we do have this outlier, and what's the effect of this outlier? So some of our measurements are not resistant. Which ones? The mean is not resistant, standard deviation is not resistant, range is not resistant, variance. So all of these measurements are going to be affected by this outlier. So we'll notice that the mean, once again, is greater than the median. And so the mean is 992, the median is 900. So this indicates that there is a right skew. So this value is skewing the data to the right. And that outlier is also inflating each of these measures. Now, the values that are not that are resistant are the median. So this 900. We can say that half of the apartments in Nassau County are 900 square feet or smaller. Half are above 900 square feet. Now, what about the percentile? What can we say about the 75th percentile? And let's just stick with Nassau County. So remember that the third quartile is equivalent to the 75th percentile. Just like this is the 50th and this is the 25th, the Q1. So I know that half are 900 or smaller, and I can also say 75% are 1,175 square feet or smaller. If I wanted to interpret the 25th percentile, I could say that 25% of apartments in Nassau County are 701 square feet or smaller. So in the next video, I'll look at the regression analysis for Queens.